Hello, everyone. I am Rick, and I'm the admin for this talk with Sean. Um, and we're just going to wait just a moment, just whilst people come in. But whilst we do that, just want to say that the session is being recorded. I do not work for Zoom, but if you have any technical problems, then fire them into the chat, and we'll see if we can help you there. If you've got any questions, also just either raise your hands, and we will have them at the end. Or type them in the chat and then I can ask on your behalf. It should be about a 20-minute talk and then a 20-minute Q&A session after that. So Sean is the host of the Advent of Computing, and today he's going to be talking about hidden code, which I'm looking forward to. And his favorite dumpling is soup
Very
dumplings.
good.
Yeah, so I'm going to go backstage now and hand over to you, Sean. And yeah, I'll
All
be
right.
back in about 20 minutes.
Howdy, everybody. Like Rick said, my name's Sean. I'm the host of Advent of Computing, which is a show about the history of computing, usually with a slant towards the more obscure and less discussed parts of the topic, because it is a bizarrely deep and obscure field. Today, I'm going to be sharing a small story about the origins of the computer virus. Just to start off with, I want to get some definitions up front. That way, we're all on the same page. So, a computer virus is very specifically a self-replicating program. Now, that can sometimes mean that it replicates itself on one computer, but in the more classical sense, it's a program that replicates itself as it spreads from machine to machine. Now, it is often done in very clever ways. There's all these tricks that programmers and hackers do to hide the viruses, to keep them out of sight, because if it gets discovered, the jig's up. You're not going to keep replicating if someone knows there's a bug somewhere in your hard drive. So, in that sense, I'd argue that computer viruses are an automated form of deception. They're programs explicitly written to deceive, to trick, and to hide, usually in plain sight. Today, we're going to be talking about the first incident of a computer virus. And to do that, our story starts with the ARPANET back in 1969. Now, this was the first network that was ever developed that spanned an entire country. It was also developed by ARPA, which is better known today as DARPA, the Defense Advanced Research Projects Administration. This is a very spooky government cutout. They're known for such hits as stealth aircraft, the GPS system, ARPANET, of course, and many, many different kinds of bombs and weapons. Suffice to say, this is the dark heart of federal spookness. Now, as I said, ARPANET starts out in 1969 and it connects universities across the nation. But initially, it's just a West Coast thing. Their first two nodes are in UCLA and up at SRI in San Francisco. The first packets actually flow back and forth over the network in 1969. Then there's a fun little story that technically the first ever message was LOL, but that was mainly because of some issues with the network. Now, the ARPANET would lead directly to the modern day internet. So, in that sense, this is a very historically important and momentous project. But I just want to highlight that this is a Department of Defense project. All the money for this is coming from taxes specifically funneled through the Department of Defense. Once again, very spooky things indeed. So you may ask, well, why is the DoD funding networking research? Well, it comes back to some research done in the earlier half of the 60s around the concept of mutually assured destruction, aka if we have nukes that will automatically fire and you have nukes that will automatically fire, no one will use nuclear weapons because we go to war, everyone dies. So these reports from the 60s were around maintaining command and control systems. Because for MAD to work, you have to be able to hit a button or have a machine hit a button and ensure that your nuclear arms will fire. These studies showed that the best way to do this was using something called a decentralized network. That's, as shown in the graphic, where you have all these little nodes interspersed, and each of the nodes is connected to multiple neighboring nodes. So it forms this kind of spider web, almost tangled mesh kind of layout. It turns out that this is actually very survivable. About in studies, about half of the network, sometimes more, depending on what gets hit, can be destroyed, and you can still talk from one end of the network to the other. And these studies, when they're simulating network destruction, are very clear that they're talking about nuclear bomb strikes on the network. How this works is pretty easy. This is the same network diagram we were just looking at. Let's say the Midwest gets destroyed, right? Which that's a reasonable scenario. That's where we keep all our missile silos, so that would be the first target for a Soviet atomic bomb strike. Well, you can see you can actually trace out a route from one side of the network to the other still. So in this scenario, a lot of the network's gone. The Midwest's in ruins, but you could still get a message to go all the way from, say, Washington over to Washington, D.C. And in that case, someone could still hit a big red button and retaliate. So mutually assured destruction is ensured. The workhorse, the backbone of this network, is this thing called the IMP, the Interface Message Processor. This is basically the first router. Now, there are some caveats. This is not very sophisticated at all. You're not doing port forwarding or gaming on this thing. But it does make up all those little nodes in the distributed map. Basically, how it works is each university that is connected to the ARPANET or each research outfit has an IMP sitting somewhere. That's actually hooked up to the larger network. To connect to the proto internet, you have to be wired into one of these IMPs. And all this wiring is done over analog phone lines. This was actually part of the initial design of one of these networks for mutually assured destruction. The idea is you're using new equipment, but you're using existing infrastructure. So it's cheap, robust, reliable, and crucially, you can use all your existing know-how around that infrastructure. So for the ARPANET, a lot of the network know-how you need to maintain it, well, the phone company knows how to do that already. That saves so much time and money and really increases reliability. Now, in practice, it would work something like this. You have your two IMPs that are connected over just normal telecom. Now, this isn't used for websites like the modern internet. It's used for remote access to computers and file sharing. So let's say you're over in California, you're at Stanford, and you have a buddy over at MIT who says they have a neat new program you want to run. Well, you'd be over here in one computer room, completely different part of the world. You wire up from your mainframe to your local IMP. That goes over the lines down to the IMP over at MIT, and then you can hook into their machine room and run code on their computer. This was primarily used not for fun, not for having a good time, not for browsing the web, but for research. And this is the outline of how a lot of early research around networking gets done. Now, crucially here, this is still a DoD project. So a lot of the research is defense related, but there's a little wiggle room. What ends up happening is, we have a lot of these computer nerds that are left loose with a really expensive, really big, really new toy. So the big question becomes, what else can you do? What is that wiggle room? One of the first projects that starts around 1971 at BBN, this is a research outfit over on the East Coast, is this idea of moving around software. Now, the core concept here is still technically defense related. In reports, this is couched in the idea of a missile defense or a radar system. You'd have this network of different air defense sectors. And while one while one portion of the network is tracking, say, a missile or a plane in their sector, they'd be running a specific program tied to that radar blip. When that radar signal moved into a different region of the network, the idea was, well, what if we pick up that program and push it over to the other computer? That way, the actual program can follow through the network running on more locally based computers as something flies over the country. Another use for this movable software would be, what if you're running some program on a computer and someone higher up with a more important program comes along? You're losing resources, but you still need to do your work. So why not pick up your program and while it's still running, throw it onto another computer that's not in the same kind of demand. The core idea here, and the reason this is connected to the ARPANET, is because to do that movement, you need a network. This leads to a program called rsexec. And how it works is you load up rsexec on each computer that you want to be able to share code between. Then you can take a program running on your computer, send it over the ARPANET, and it will show up on another computer running rsexec. In this instance, rsexec acts like an open door. It's kind of a red carpet saying, hey, I'm ready to accept new programs to run. Now, of course, any good project needs a demo. The demo for rsexec was called Creeper, or Creeper. This was developed by a programmer named Bob Thomas, who was working at BBN. And like I said, it's meant specifically as just a demonstration, something to show off that, yeah, rsexec does work. It traveled over the ARPANET from computer to computer, and crucially, this is a very fastidious program. It would pick itself up, clean up, and then move. So it never left copies around, didn't leave temporary files. It was a good guest. Now, the name I think obviously comes from this. It literally creeps around the network. And this is what it actually looked like if it came to pay you a visit. This is a scan of an old terminal printout. Now, it was way back in the day, it was 1971. So we don't have nice CRT displays. If you do, that's because you have a lot of money. Most places were using these hard copy terminals where you have an actual reel of paper with a typewriter, an electric typewriter that hammers data into it. When Creeper came to pay a visit, your terminal would turn on and it would say one thing: I'm the Creeper, catch me if you can. And then it would bounce. It would hop off to another computer somewhere else on the ARPANET. It would look for another one of those red carpets that rsexec rolled out. A lot of people say that Creeper is the first computer virus, but there's a few caveats there, a few little daggers. The first is these are fully scheduled demos. It's really easy to fall into the trap of, oh, it's a program. It's a ghost in the machine hopping from computer to computer. Imagine it's late at night. You're slaving away in the server room and you hear a click, click, clack from behind you. You turn around and your terminal out in the back corner of the room is hammering out, I'm the Creeper. Catch me if you can. Right? That would be a great angle to the story, but that's not exactly the case. These are fully scheduled demos. It's more like a group of researchers, probably a group of undergraduates, would go, oh, hey, it's Thursday afternoon on March 15th. This is the scheduled demo time for the Creeper. So they go to the server room, gather around the terminal, and wait for a few minutes. They'd see that I'm the Creeper, and they'd all go, oh, wow, that's some cool software. This also doesn't replicate itself. As I said, Creeper's very fastidious. It's a nice, clean kind of program. So it's not classically a virus, but it's very close. We hop over that fence into full virality very quickly, though. The same year that Creepers developed, another programmer named Ray Tomlinson modifies the program. And crucially, he removes the cleanup step. This means that Creeper is now self-replicating. So you start it on one computer, and then it starts running on another computer. It's not jumping and bouncing around anymore. It's spreading like a disease, like a virus. Crucially, each of these programs still has that little bit that says, go spread to another computer. So you run it on one, it starts running on two. If it's running on two, it starts running on four, and then 8, 16, 32, on and on until the entire country, every computer on the ARPANET that's compatible is running Creeper. That does make this the first computer virus, with the caveat that this isn't malicious yet. This is still a demo. It's scheduled, it's expected. It's a Thursday afternoon. Everyone gathers in the server room and goes, oh, gee, isn't that some neat software? This leads to another development. Another traveler called Reaper. Now, usually how this is framed in interviews is that Tomlinson was concerned, as most programmers are. He was tossing and turning in the night, worried what would happen if he wrote bad software. Because when you get down to it, everyone does. There's this old adage that's attributed to Rear Admiral Grace Hopper, which basically boils down to the number of bugs increases proportional to the number of lines of code. So the best way to write functional software is to write as little software as possible. That means that Creeper could have bugs in it. What if something goes wrong and it never stops replicating? What if it starts doing more than just printing, I'm the creeper, catch me if you can? Maybe he didn't terminate a string. Maybe there's a dumb loop that just eats up all the resources on someone's computers. So Tomlinson implements a kill switch. He writes a program called Reaper, and all it does is kill Creeper. It uses the same framework of rsexec. It goes from computer to computer, looking for anything running Creeper and clean it up, killing the program and deleting it. This is, in many ways, the first example of an antivirus. And it's funny that it's using the same framework as this first virus. Now, the scenario I've just laid out is the first incident of a living or a live computer virus. But it's not really the first virus, if we're being really strict. That's actually from 1970, a full 2 years previously. In that year, an author named Greg Binford publishes the short story called The Scarred Man. It shows up in Venture Science Fiction and pretty much nowhere else. It's pulp sci-fi. If you've ever read the kind of story, then you know what I'm talking about. These were little dime store magazines that would be chock full of fabulous stories. It's where authors like Isaac Asimov get their start. And The Scarred Man, like many in the genre at the time, it wasn't a very good story. Binford even admits to as much later in life. These were often paid for by the word. They're just fun little throwaway stories for you to read on a lunch break or maybe in a couple extra minutes while you're waiting for the subway. But The Scarred Man is interesting because it describes a computer virus. I just want to give a few highlights of this story. The first one is it stars this shadowy programmer that develops a program called, and this is directly from the text, virus, right? That's kind of weird. It spreads from machine to machine, replicating. Once again, that's kind of weird. It moves over phone lines specifically. This is something that is explained in great detail in The Scarred Man. It doesn't talk about a network, but it talks about mainframes being connected to each other over phone lines. The virus, well, virus itself, when it loads up, would start randomly dialing numbers until it got a certain pickup tone that it knew meant a computer was on the other line, at which point it would jump itself over to the new computer and pick up from the beginning. The payoff, besides doing malicious things and wreaking havoc on a target computer, was that this very programmer sold a very legitimate program called antivirus. For a very reasonable fee, he could solve all your virus problems. Now this sounds very similar to what we've been talking about, right? In the case of Creeper, we have a salaried programmer that develops a program, Creeper and Reaper. It spreads from machine to machine, it self-replicates, and it moves over phone lines. The main difference is the payoff here, instead of some kind of, antivirus program making money, is having a fun time learning about computers. And in theory, maybe you get some research grants out of this. This kind of sets up the framework for all future viruses. Creeper, very much as an outline, is the same as later computer infections. Something like Heartbleed or even the I Love You virus follows the same kind of protocol. It spreads from computer to computer, it self-replicates, and it has some kind of thing that it does once it gets on your computer. The key difference here is deception. Creeper is very explicitly a demo. It's something everyone knows about, but that same framework, that same idea of spreading around using some kind of entry point is later used to deceive. In this case, rsexec is there as an open doorway, but later on, viruses find their own ways in. It turns out that it's not that hard to break into a computer. The real trick is hiding once you get there. Now, just one other point that I want to bring up that is a neat little coda here. The Scarred Man actually disappears from the historic record quickly after it's published. Like I said, pulp sci-fi is meant to be thrown away. That means that up until, I think around the late 90s, early thousands, no one remembers the Scarred Man exists. It's not until it's republished that a lot of discourse around the literary origins of the virus start to come up. So that makes it all the more interesting that the virus shows up in science fiction before it ever shows up in person. All right, that's all I have for today. Thanks so much for listening. If you like this kind of story, I produce this kind of stuff every 2 weeks over on my podcast, Advent of Computing. You can find that everywhere you listen to podcasts, or you can go to adventofcomputing.com to find links to my Patreon, to find information about the show, all that good stuff. Any questions?
Thank you, Sean. That's really interesting. Let me just get my Windows open.
Yeah.
Yes, if anybody's got a question, you can raise your hand or type it in the chat. Whilst you're having a think, it's interesting what you're saying about the Scarred Man, how that kind of predicted
Yeah.
these concepts and even the naming and the terminology used, which I guess is understandable with how viruses work in biology, but that it's still picked up is
What gets really weird is it's not until the later half of the 70s, when people are actually doing research around malicious code, that the term virus shows up again. So we have this
Mhm.
kind of just forgotten blip in a random pulp magazine that uses virus. And then for a while, people don't have like a unified term for this kind of software. It's it's just a fascinating field.
Yeah, definitely. Do you think that this with the RS6X that was giving a very clear doorway in to execute this code or move the programs around?
Mhm.
Do you think people were almost naive at the time and not expecting it to be used
Well,
maliciously?
I think part of it has to do with audience. So the ARPANET was explicitly a DoD project. You had to adhere to certain governmental guidelines to use it. And one of those was you're not really supposed to be messing around with other people on the ARPANET. You're using it for research specifically. There's actually some cases in also in the 1970s. That's really the decade for this stuff, where some students get arrested because they're protesting using the ARPANET. And yeah, freedom of speech exists, but this is a federal defense system. It's not meant for protesting, it's meant for research. And you have to sign like
Mhm.
riders to even get on the network.
Okay, yes, there's a barrier to even get in there.
Yeah. Yeah, it's not
As
like the
yeah,
open internet today.
yeah. Okay, I've got some questions coming in. So, Doug asks, when did the first malicious virus occur?
Depends on what you mean by malicious. The the first virus that goes around that causes actual issues is in the early, I want to say early 80s, late 70s. It's this virus called the brain virus. Very spooky. That's the thing. A lot of these early viruses have great names, but the brain virus was meant as some angry copy protection. So it's this company who notices their software keeps getting copied. So they send out some disks to market to be sold as bootleg software that has a virus that'll lock up your computer if you're running it and say, "Hey, you got to send us some money. Here's an address to send us a check and we'll send you the right software."
That sounds pretty familiar to things that happen today as well. It hasn't
Oh
really
yeah.
changed. Yeah, except in this case, it's the company who make the software themselves doing a pretty bad PR thing there.
Yeah, I mean, I think I'm trying to remember the interview. I think they got like $20 or $30 or something out of it eventually. So
Wow.
it paid off. It
Uh,
worked. Maybe not the best idea though.
no. Um, okay, we've got Steve in the chat. He's just said that he teaches science fiction, and the
Mhm.
best, if not the best written science fiction, is always linked to the real world.
Yeah, that's definitely the case. Any other
Um,
example?
if anybody wants to actually say that, ask their question, just stick your hand up, and I'll give you permission to talk as well. Um, so I don't know if Wesley, if you want to ask in person, or I can raise your question out for you. I've allowed you to talk if you want.
Welcome. I think they're on mute
Okay. Oh no,
still.
he says I go ahead. Okay, yeah. Sorry, I just said. Okay, so the question is, I guess, sorry, I guess
Yeah.
we're somewhat lucky that the person who made the Creeper program did not want to do something more malicious. I feel like early computing is full of similar stories. Do you know of any other fun examples of people just having a bit of fun with early computing that would um, stage later more malicious activity?
Yeah. So the one of the reasons that I know a bunch about viruses is I've been doing an ongoing series on this show. Every Halloween, I do an episode on the history of viruses because there's so many. Um, but one that was just for a bit of fun. Turns out a lot of early viruses were for fun. Is called Elk Cloner. And I have no idea where the name comes from. There's been interviews with the guy that wrote it, and he's like, "Yeah, I was just messing around. I don't know why I thought that was funny." But he was a high schooler who was working on Apple IIs at the time, and he wrote this program that would copy from floppy to floppy, which turned out to be a really good vector because this was back in the day where you'd have two floppy drives. So you'd, if you want to share a program with your friend, you would copy that floppy, right? You throw in a disk, make a copy of it. So he started passing around disks that had this malicious program hidden
Mhm.
inside it. And it had a random delay, and then it would either, at the flip of a coin, do nothing, turn your computer off, make the screen go dark, or make both of your floppy disks start like clicking and scraping. And that was it. It took like months for anyone to realize what was going on. And by that time, there were hundreds of these floppy disks that just randomly would make your computer like go dark and go like click, 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 click. It must have scared the bejeebus out of at least a few
Yeah,
computer users.
yeah. I
But
think they're
once again,
supported.
yeah, and once again, it was one of those things where it's just like, haha, we're gonna have a good laugh. But it is using that same framework of deception that is also
Hmm.
used for actual malicious bad viruses later on.
Yeah, and at the time, then there wouldn't be the, well, maybe the infrastructure to either disseminate the knowledge of the virus
Yeah,
or then to clean it up. And how do you actually then
exactly.
remove it? It's not like you've got a virus scanner which
Hmm.
it's going to regularly check.
Well, the only infrastructure would be sending around newsletters and magazines, which I mean, that's very hit or miss. Like, are you gonna go
Yeah.
spend $7 down at the like bite shop to get the right magazine that tells you to watch out for that floppy disk? Probably not.
Hmm. Hmm. How do you see like landscape changing in terms of viruses? Because it seems like there's a running battle. Because I remember when I was, I don't know, back in the early thousands or something, they seemed like a real threat all the time. But now
Mhm.
I didn't feel particularly scared of viruses.
Yeah, I think a lot of it has to do. So in the 90s and thousands especially, it did feel like an arms race, right? Um, Now the exploits are few and far between. And I think that's kind of a two-prong reason why the arms race has shifted largely towards the defender. One of it is a lot safer programming practices. As programming has become more professional over time, there have just been a lot better practices around testing and especially doing like penetration testing and having dedicated
Hmm.
people. It's usually called red team, blue team exercises, where you
Yeah.
have dedicated people who it's like, my specialty is breaking your computer. I'm going to come try to break your computer, but you pay me and I tell you what's wrong with your software. And then also having things like virus databases that can be updated over the internet. That makes it a lot easier. And that wasn't really viable during the dial-up days or when the internet wasn't as integrated into software as it is now.
Yeah. Do you think there's a trend maybe for more social engineering attacks as well, as everybody's connected rather
Mm,
than targeting the software? Let's
yes.
actually target the people because the people are the stupid ones here.
Well, social engineering's always been a huge threat. But yeah, that's the big attack vector now. I work professionally in software and I have to do security training every year. And it's stopped being about update your computer, do this, do that. And now it's almost entirely about
Mhm.
don't click on links. If someone calls you, verify who they are. And if you get a text saying it's the CEO asking for a Steam gift card, don't give him a Steam gift card. He doesn't need that. Why would you do that?
Yeah, they're always the weak link.
Yes.
Okay, Steve has asked in the chat, looking ahead, if we can, how could AI be used to spread viruses if it can?
Ooh, that's a good one. So it's easier to think about the other way because antivirus software works off detecting a virus, and that's usually done with a signature. It would be really easy to train it like something similar to an LLM to figure out signatures of viruses. The other way, though, hmm, my first thought would be polymorphism. So there's it's getting kind of technical, but there's this idea um, of a polymorphic virus, which is where to get around signature checking, you have a virus that changes as it spreads from machine to machine. And it wouldn't be a substantial change. Usually it's something like you're just modifying the kind of outline of the virus. You'll be adding some junk code, removing some junk code, shifting stuff around so that if a program comes along and an antivirus software is like, oh, do I know this program? It looks at it and it's like, no, I don't know what that is. Um, Nowadays, a lot of antivirus software is good at detecting that sort of behavior, but you could, in theory, use AI to try to learn. You could train it on how antiviruses detect polymorphic viruses, and you might be able to teach it to like, or have it figure out a way to like get around the detection mechanisms. That would be like my off the dome guess. I'm sure there's a smarter way to do it though.
Okay, I've got another question here from
Mhm.
Wesley. I know in early computing, simple programs were often distributed as source codes in magazines, news groups, newsletters, etc. Do you know if that was ever a vector for distributing malicious programs?
That's a really interesting question. As far as intentionally, I don't know. I'm gonna look into that because that sounds fascinating. There were oftentimes so because these types of type in programs were in magazines usually, and the magazines, the early home computer zines were very small staff, almost no resources. Sometimes I have a bunch in my collection. Sometimes they were like done on mimeographs on like really thin paper. There were a lot of errors in those programs. So it's funny, you can look at some type in programs. It's like, oh yeah, type this in, it'll print this, it'll do this. And then you can look at the next issue of the magazine, it'll say, actually, don't type that in. There's a bug in it. You need to change this line or it'll lock up your computer or it's supposed to solve some math equations, but it actually doesn't work. Here's the revised version. But as far
Yeah,
as intentionally bad code, I'm going to look into that. That's really an
mm,
interesting angle to think about.
yeah. He just added, I can imagine somebody on a Usenet text
Oh,
post
yeah.
having a lot of fun distributing something to mess with your PC.
Yeah, I know people used to do that over BBS, like bulletin board systems back in the day. I'm pretty sure Usenet worked as a similar vector because anytime you have networking, you can pass around viruses.
Mhm. Oh, one thing I remember happened to my dad was he used to have one of the little Scion computers,
Mhm.
and somebody posted on like one of the early kind of forums or something, enter like 127.0.0.1 into the device, which is obviously local host. And you'll see these
Mhm.
people that they've got all this stolen software on there, and you can go and delete it. So people started doing that and deleting the software from their own machine.
Once again, we are the weak link.
Yeah.
No amount of software can get around us.
No. Uh, Speaking of the weak link and say AI, one of the podcasts I listened to, the host has started using AI to write various scripts or bits of code to help him automate
Mhm.
various things that he likes to do. But you could almost see, because they don't have the background in programming and securing the code, or even just maybe not securing it for outside influences, but making it safe to run on their own data without being destructive to their data.
Yeah.
So it's almost a virus that people are writing to affect themselves potentially.
There's there's this fabulous paper that I recommend anyone with a passing interest in programming read. It's called On Trusting Trust. It's written by Thompson, one of the authors of Unix, but it's about how when you trust software, that introduces a possible vector for a virus. Um, and that's a very similar issue. In that paper, he's talking about how it would be possible to hide a virus inside programming tools and do it in such a way that you'd never notice. Because most of us don't look inside tools. We're like, here's a hammer, thanks, I'll use it. Um, but with AI, that does introduce another similar vector. If it's writing code and you're like, I don't really know how to program, I'll just use it. Sure, I like this hammer. That introduces a vector every time you trust something. So yeah, that's a very good point. That could be very dangerous to trust.
Yeah, I've used I know GitHub Copilot and different ones to
Mhm.
like aid me with my programming, and the amount of times that it might give me something that kind of works, but I have to have the understanding to fix it, or it will be giving me like code for an older version of the framework, or just that
Mhm.
level of knowledge which people don't have, but then they are introducing themselves to complex code that can be run. It's just going to spell disaster. So
Yeah.
I think it's
Well,
the next virus is going to be ones people write themselves.
yes, exactly. And that's something that's really interesting working in the industry right now is at my company, we're spending a lot of time, at least higher up, trying to work out policy for how you should be using things like Copilot. And so right now, me and a couple other programmers have been sitting down every couple of weeks and going through and trying to figure out like what what is ethical, what is safe, and what is productive to do with this. The first one we're going to start introducing is doing automatic code commenting because
Mhm.
that's super low risk. That's not going to give you a virus as long as it does actually write comments. And it's something that we've seen the AI models are pretty good at. But as far as writing actual code, that's going to be really hard to vet. And we're having a lot of problems. And I think a lot of companies are having a lot of problems figuring out like, how do you do this safely and responsibly?
Yeah, yeah. How do you make sure everything's tested thoroughly enough?
Yeah. Yeah. And you're not just going, that looks really complicated, but it seems to work. Why not?
Mhm.
I'll
And it's
I'll
quick
send
and
it.
cheap.
Yeah.
Actually, Steve wrote in the chat, once programs become smarter than humans, we are doomed.
Yeah, luckily programs at the end of the day are eventually written by us. Even if it's AI, that's still written by us.
Yeah, as long as we can
But yeah.
unplug them, I'm happy. It's when we
Yes.
can't start unplugging things, that's when it gets scary for
Yeah,
me.
I'm not very big on having waterproof electronics.
No. Right, let's see. Does anybody else have any more questions or not? We'll give them a moment to. Is there anything else you want to add, Sean?
No, I'm all set.
You all set? Okay. Do you want to like plug the podcast again? Let
Yeah.
people know where they can find you.
Yeah, so the show's Advent of Computing. You can find it everywhere. My website is adventofcomputing.com, and that has links to my Patreon, I don't think it's updated for my Blue Sky right now. I should do that, but it has book recommendations, all that good stuff.
Excellent. Thank you very much.
Yeah,
Yeah, I think that probably covers it then. That's really interesting. And like
thanks.
the first kind of viruses were just case studies that people were testing.
Yeah.
So
Yeah. And like I was saying, it's a super interesting topic. And if you want more specifically about viruses, I do have, I think, 4 episodes now going through viruses throughout the eras. Um, it's just a really fun topic.
Definitely. Thank you very much.
Yeah,
Right.
of course.
Okay, thank
Thanks.
you. Okay, I am going to end the webinar now. If people are interested in the roundtables, then that's on a different Zoom lobby. Unfortunately, there should be links available though in the lobby for the regular talks. And there's going to be one more session now. And then I think there's a keynote and then the lunch break and then back onto the regular programming after we've eaten. So yeah, thanks very much, everyone.